So for anyone who doesn't know me already, my name's Claire. I'm one of the TAs at Launch School. I'm also a student and I'm in the front end of the core curriculum. This is the second in a series of introductory workshops on Python. They broadly follow the Programming a Backend Prep Python course. They'll give you a flavour of what's in the course materials, but they're not a substitute for working through the materials yourself. Let's have a look at what we'll be covering today. So we're going to look, so last time we looked at data types and variables, excuse me, and this time we're going to look at functions and variable scope. And we're going to look at what is a function, we're going to look at parameters and arguments, what's the difference between them, function return, so what you get out of the function, variable scope, and then functions versus methods. There's going to be time at the end for further questions, but if you've got something that's related specifically to what I'm talking about, then please put it in the Q&A and I'll answer it as we go along. If you put it in the chat, it can get a bit lost, whereas the Q&A has got functionality for me to record and keep track of which questions I've answered. I'm going to put a link to the feedback form in the chat now, so anyone that needs to hop off early can grab it. We read every piece of feedback we get at Launch School and we are constantly adjusting things. So please let me know what worked well for this workshop and what didn't work well and how we can improve it for next time. If you want to code along with me, please go ahead, but don't worry if you can't, because I've got lots of quizzes to keep things interactive. But the quizzes are for fun, they're anonymous. I can see how many students have answered particular questions, but I can't see who has. So don't worry about getting them wrong, because it just doesn't matter. We recommend using a Mac and Visual Studio Code as your code editor. That's what I'm going to be doing today, but it's fine to use a Windows machine or use AWS, whatever. Launch School's Python book has got instructions about how to get up and running in these different environments if you need it. If you've got any problems though, go on to our Slack. If you're not there already, it's a great way to get into the community. There's lots of different groups there, including Gratuitous Pet Photos is my personal favourite. But there's a prep course channel, and that one is specifically for people that are in the prep course. And if you've got any issues, anything, then post a question in there and a student or a TA will come along and they'll help you. Because often getting started is the hardest thing. And then once you've got your machine all set up, and then you're good to go. Okay, so let's get going then. So I'm just going to get rid of this and get back to Visual Studio Code. Hopefully, there it is. You can see it on the left, I've got my VS Code, and then on the right, I've got the notes for today. And we're going to do what is a function. So functions are reusable chunks of code. They might be built in, and these are functions that are always available in Python, or they might be custom made by the programmer. So before we start building our own functions, we're going to play around in Python's REPL to just what I need is return. I'm going to play around in Python's REPL just to show you a few of the built-in functions. So to get into the Python REPL on the terminal line, you type Python. If you haven't got your path variable set up as you should, this is all in instructions, then you might need to type Python 3. Mine's set up, so I'm all fine. And then Command K just clears the screen for me. So one of the first functions, built-in functions we might introduce you to is print one, so that we can output something, because it's quite useful to be able to see things. We can also look at maybe the length of a list. So len, and then we've got our curly braces, and then we've got our list inside. So that's going to tell me 5. There are 5 things in there. We can also do the length of a string. So that's also 5. Hello. Another really useful one is type. So I want to know the type of a piece of data. So if I've got a variable pointing to something, it wouldn't be as obvious. Obviously here, I can see that at one point is a float, but you get the idea. You can use type and it will tell you what data type you've got. Another great feature of Python is help. And here you type in the you pass in the name of the function that you want help with. So here I want help with min, and then it brings up all this helpful stuff. So this is telling me I can either, there are two options here, and actually, once you get used to looking at this, you'll probably be able to get most of the information you need from these top two lines. But when you're first starting with this, then read the sort of plain English part of it. So with a single iterable argument, so iterable just means something we can iterate over, so maybe a list or a tuple or a dictionary, things like that. With an iterable argument, it will return the smallest item. And then if we use a default keyword as a parameter, if we use a default keyword as an argument when we're calling this function, it will specify what we want to return if we're passing in an empty object, so an empty list or an empty dictionary or something. And then the second way to use it is just use min, and then you just use comma delimited list of things that you want. So not an actual Python list, but just things that you want to find the minimum of, and it will just return that. So if we just press Q to get out of that, so we can see this in action. If I do minimum of a list, here it's going to give me 2. But if I did the minimum, and I didn't create a Python specific list, but I just put a bunch of things in, then it will also give me the smallest one. So that help function is really genuinely helpful. So if you're not sure how to use a particular function that's built in, help and that, and then you're on your way. Okay, so to get out of the REPL, we do Control D. And so I'm now back to the command line. I'm just pressing clear, so I'm not cluttering up the screen. So custom functions are helpful when you've got functionality you want to repeat over and over again. So it makes the code easier to maintain, because when you want to update it, you've only got to make those changes in one place. It makes programs easier to read, because you give your function names meaningful names, and then you can tell what the intention of the code is, and that makes your code just so much more readable. Now, functions can be thought of as like a set of instructions or a recipe. So today we're going to create a function for making a delicious pasta sauce. So what I'm going to do here is create a new Python file. So I'm going to do touch to create the file. I'm going to call it recipe. And then I've got py as the extension because it's a Python file. So if I do that, and then up here, I can just get my Explorer and then double click that to open it. No, I can get rid of the Explorer. I'm just going to get rid of this down here. So now I'm in my recipe file. I'm going to put in the chat for anyone that's coding along a gist link so you can get the code. It's hosted on GitHub, but you don't need a GitHub account or anything. You just click on that link and you'll see the code. So I shall click on the link and then you'll see it. Okay, so it comes up here. So I can just copy this code. And then I can just paste it in. So we're just using the print function here with a string passed in as an argument several times to output information to the terminal. So if we just save that and then go back to the terminal, I can now run this file by typing Python and then the name of the file. So Python recipe py. Do that, and then it outputs all of those strings because I was using the print built-in function. So now I want to demonstrate how we can turn this into a function. So again, I'm going to paste in a link for anyone coding along. And I'm going to go back to here. Now here we can see I've got these two lines, pick up wooden spoon and stir pan, repeated 3 times. So it'd be useful if that was in a function. So I'm going to create a function. So I'm doing def, and then I'm going to call it stir pan. Then I follow that by round braces, parentheses, I think we call them. Yeah. And then I'm going to just copy these 2 lines of code. I'm going to put them in here, make sure they're actually in there. And so now I've created a function. Because I've created a function, I can now get rid of these 2 lines and I can just invoke that function like that. And I'm going to put that everywhere instead of my 2 lines. So now this should do exactly the same as what we had before. But let's just have a little look at the syntax before we move in. So function definitions begin with the keyword def. Then you have the name of the function. Then you have these parentheses, simply moving something, then a colon. Then all of the code that you want to be inside of that function needs to be indented for 4 spaces, because Python knows that the function definition ends when the indentation ends. So there's no end that we put here or a bracket ending or anything like that. Python just knows the definition ends because the indentation has ended. So we've got our function up there, and then this is the code that's going to be executed. So make sure we save that, and then we'll go back to the terminal, and then I'm going to clear the screen, and then I'm going to run the code again. And we can see here we're getting exactly the same thing out as we did before. But using the function just means that we don't have to repeat these 2 lines of code all the time. So another advantage that creating a function provides is that if we want to change the instructions for stirring a pan, we can now just change them in 1 place rather than having to change it in 3 places. So I'm going to add an extra command to this. So we're going to pick up the wooden spoon, we're going to stir the pan, and then we're going to remove. Let's place that back up there. And then we're going to remove the wooden spoon from the pan. Now, previously, I would have had to have put that in 3 different places. Not quite sure why it's not liking that. Maybe we need to. There we go. Before I would have had to have put remove wooden spoon from pan in 3 different places, but because I've created my function, I can just put it in 1 place. So now, if I save that file and then run the file, let's clear the screen again. Now I've got that remove wooden spoon from pan repeated 3 times. So you can see just by adding 1 print statement to the function, I've changed the output in 3 different places. So now we are going to do the first quiz. So I need to come off of here so you can't see the answer. Oh, you can see the answers there. There we go. Don't want anyone cheating. We've got what is the function there, and then we're just going to clear that screen. So I'm going to start the what is function. I'm going to launch this. I'm going to give you a couple of minutes, and then we're going to go through the answers at the end. Remember, this is just fun. I can't see what anyone's answering, okay? So go ahead and have a go. Okay, I'll just give another 15 seconds or so. If I'm not giving long enough for the quizzes, please put something in the chat, and I'll make sure that I'm not rushing you so much. Okay, so let's have a look then. So I'll just end that poll and then I can share the results. Then show you the answers here. So for the first one, what are the purposes of creating functions? It's all three. It makes code easier to read, it reduces duplication of code, and then it makes the code easier to change as well, because you don't have to find all of the different places you did this. It's all in one function. You go to that function and then you can make the change. The keyword used at the beginning of a function, everybody got this right, is def. How could a function named start process be invoked? Everyone got that. Nearly everyone got that one right. So it's start process. Please zoom in on this a little bit. Oh, I think that might be a little bit too big. Here we go. So what we want to do is start process followed by curly braces. That's how you invoke a function. You need to put the curly braces after the name of the function. And then for the last one, the end of the function definition is denoted by reduced indentation, which to me made the code look a little bit naked when you're coming from Ruby, but now I'm used to it. Actually, it just, Ruby now looks cluttered with all of these ends everywhere. So now let's move on to passing information into function definitions. So we've actually already used arguments every time that we've invoked the print function. We've passed in a string as an argument. So parameters and arguments work together. Parameters are used in function definitions and arguments are used in the function invocation. So when we invoke a function, that's when we pass an argument. But when we define the function, we use a parameter so that Python knows what to do with the argument that we're passing in. So if we have a look at this function we created, say if we want to vary the way in which we stir the pan, we can update our function to include a parameter, and then we need to pass an argument. So I'm just going to paste the gist link in there for anyone coding along. What we're going to do is we are going to pass in a parameter. So we're going to define a parameter, so stir style. And here I want to stir pan, and I want to have the stir style in there. But because I want to put a variable inside a string, I need to turn it into an F string, which I do just by putting an F in front of the quote. So in Python, it's really easy to put variables inside strings. You just use an F before the quote, and then any variables that you want Python to interpolate inside that string, you just put inside curly braces. And then when the code is executed, Python will substitute the value for that variable inside the string where you put the variable. So now outside, I'm going to create a variable called speed, and I'm going to assign it to slowly. And so now when I'm invoking stirpan, I need to pass it this variable. I thought if I didn't talk, I might find it easier to type accurately, but no. Okay, so just have another look at the syntax. We've got the name of the function. We've then got the parameter inside the round braces. We've created an F string so that we can put a variable inside a string, which we put inside these curly braces. Then we've created a new variable speed, assigned it to the string slowly. And then when we're invoking this method stirpan, we're passing speed as the argument. So if I now save this and go back to the terminal and then run this code, now we can see I've got stir pan slowly with wooden spoon. So again, it's made that change in 3 different places because I'm invoking that function 3 different times. Now, here you can see I've used different names. So I use stir style as my parameter and I use speed as my argument. You could use the same name for both. I could just put speed inside here as well. But I just wanted to show you that they don't have to have the same name. So the variable outside of the function that you're going to pass in can have a different name to the parameter inside the function. So we're now going to have another quiz to check your understanding of parameters and arguments. Now, some of the questions relate to examples in the student notes, which I'll have up. And here they are. I don't really on the screen. Yes, I can. Now, some of these questions might introduce new concepts because I thought it would be more interesting to do it this way than me just talking all the time. So don't worry if some of this is unfamiliar, because I'm going to go through the answers at the end. And again, I can't see who answers what. So let's do the parameters and arguments. Please. Let's have this little bit of being nervous when I've initialized a new quiz when no one's answered the questions, but there are like 7 questions, so you do need to think about it. So it's fine. I'll be relieved when one person has completed it. Oh, is there an example 5? Oh no, I didn't get it all on there. Okay. I will need to get it all on there. No. I need to make this a bit smaller. Oh, just maybe I should, if I just remove these carriage returns, let's do that. And it's all on there. I think there isn't an example 6 and 7. I think those questions, those are just questions. You don't need code for those ones for you because I can't fit any more on the screen. Okay, I'll give you another 20 seconds or so. Shout in the chat if that's not long enough. Okay, right, let's go through the answers. Those results. And then we're going the answers up. So I'm going to zoom in again now because we don't need to see all of them at once. Okay, so for question 1, this demonstrates using a value as an argument rather than a variable, which actually we do with print. We've already done with print loads of times before. So this outputs, there are around 700 separate programming languages. So we can pass values directly as arguments into functions as well as variables. So the second example, this is demonstrating using multiple parameters and arguments. So we just do them as a comma delimited list. So in the definition, we've got first name, comma, last name. So there are 2 parameters that are passed in. And then when we invoke that that function, we pass in our 2 arguments. They are also comma delimited. And so the order matters because Alan is going to be assigned to first name and Turing is going to be assigned to last name. So we get Alan Turing cracked the Enigma machine. Question 3, here an error is raised. So this is demonstrating if Python expects an argument and you don't pass one, it will raise an error. So here we've defined virus as taking a parameter year, but then we've invoked it without passing anything in. So Python will say, there's an error, you wanted to do something. Not all languages do that. So JavaScript is a bit free and easy and will let you invoke functions when it's expecting arguments and not passing them in, and it will just carry on. But Python's a bit stricter about these things. It's got strict arity for functions. But then example 4 demonstrates using a default parameter. So here inside the function definition, if we do the parameter and then equals a value, if we don't pass in a value, like we haven't here with print out, we don't get an error because Python says, oh no, it's okay. You told me if you didn't pass in an argument, I should assign name to Ada Lovelace. So this one outputs Ada Lovelace was the world's first computer programmer. And then example 5 is just demonstrating overriding a default parameter. So although we have assigned a default as the Carnegie Institute for Creator, because when we invoked printout, we passed Arthur Samuel, it is the first AI program was created by Arthur Samuel is what will be output. So it's quite flexible like that. If you have a default, it'll only be used if you don't pass anything in. If you do pass something in, it will be overridden. Then for question 6 and 7, arguments are used in function invocations and parameters are used in function definitions. The more you use it, the more you remember that. So don't worry if you didn't get it right. Okay, so now we've looked at how to get information into a function. We're going to look at how to get information out of a function. So that's returns. So before we do that, I just want to do a quick recap for anyone about the difference between an output and a return, because we're talking about returns here and not outputs. So when I use the print function, Python is the best. Python is the best is what is output. But what is returned by print? So if I assign that to a variable, it's outputting that because it's running the code, but I've stored what was returned by that expression print Python is the best into a variable A. So now if I print A, let's see what comes out, none. So with the print function, it outputs what you're passing as an argument, but its return is none. So all I'm demonstrating here is that the return and the output can be, and often are, different. All the functions we've created so far in this workshop have provided outputs using the print functions. That's what we've been looking at. But now we're going to be looking at what functions return. So I'm going to go back to the terminal. The screen. And we're going to create a function that takes an integer representing the number of servings for our pasta sauce, and we want it to tell us how many tins of tomatoes we need to use. So I'm just going to create a new file and I'm going to call it servings. And I just need to open that up. So now I'm inside my new file. I'm going to paste another gist link for anyone coding along. And I'm going to copy that code in myself. So you don't need to watch me type. So here we've got a function. We know that because it's starting with def. Then we've got a number of tins, and then it takes a parameter number of servings. Then inside that function, we've got a return keyword, and we want it to return the number of servings divided by 2. Then down on line 4, all I'm doing here is I want to capture that return value so that I can print it out and we can see it. So I'm sort of turning that return into an output, but it's just so that we can actually see what's going on. So I'm invoking the function number of tins and passing 6 in as an argument, and I'm capturing that in the variable returned value, and then I'm printing returned value so that I can see what this function returns. So if I save that, go to the terminal, and then execute, then run the code using Python, I can see I'm getting 3.0 out. So because I've used the explicit, because I've used the return keyword, this is an example of an explicit return, because I'm explicitly saying return something. So one thing that's important to know about the return keyword is that if you put anything after the return expression, Python won't execute it. VS Code is quite helpful here because I don't know if you can see it, but this line here is a bit grayer than the other line, so it's giving me a clue that this isn't going to be executed. If I save this and then execute the file, you can see print high is not being output. So once Python executes a return expression inside a function, it then exits the function, nothing else is executed. So that's an explicit return. We're now going to look at an implicit return. So if I just get rid of this return keyword here, but I'm going to execute the code as I did before. I've just got rid of the return keyword. Now I can see none is coming back. And that is because if you don't have an explicit return for a function in Python, it implicitly returns none. And that can catch you out if you're used to languages such as Ruby, where the last value is the thing that's returned. That's not what happens in Python. If you want something returned, you need to use the return keyword. Otherwise, Python will return none. Okay, so now we're going to have another quiz on some different functions. So I've got some code snippets again. Okay, a few this time, so I can zoom in on them. Oh, I didn't stop sharing last time. So now we want to look at function returns. So have a go. This is only 3 questions. It's just fizzy water. It's nothing alcoholic in there. So it won't pop. Okay, I'll give you another 20 seconds. I've got a question, so you can have a little bit longer while I just answer this question. Someone's asking how you plot the help function. So you need to be in the Python REPL, and then you type help, and then the name of the function that you want to put in there. So I could put in a different one this time, help len, and then that will give you help on it. So just make sure that you're in the REPL by typing Python, then help, and then the name of the function you want help in. You're welcome. It's really helpful. Many years ago, I learned a computer programming language called MATLAB, which is still used today. And I went on like a 2-day course, and they taught us in the first morning how to use the help function, and then they left us to it. And actually, it was genuinely helpful, the help function in MATLAB. And I feel like in Python, it is genuinely helpful too. Right, okay, so let's have a look at the answers. So share those results. So for the first one, this is demonstrating an explicit return here. So we're going to get 3 returned because we've got the return statement here. So and see, I took out the executing code here because I wanted to fit more on the screen. I think I needed it for the one. For example, 2, we've got print. So it will print out 8. That will be the output, but the return will be none because we haven't got an explicit return statement there. So we'll get none. And then for example, 3, we have an explicit return. So it will return game, but that means that it won't print out that last expression here. So the question was, what will be output? Nothing will be output because the print statement won't be executed because Python won't get to it. It will come out of the function before it gets to it. A return game isn't outputting anything, that's the return. Oh, that was a bit sneaky, that one. Okay, so now we've looked at how to pass information into and out of, I'm going to have to make it small again, into and out of variables, functions. We're now going to have a quick look at variable scope. So what is variable scope? So variable scope describes where a variable can be accessed. Brandon, thank you for that note on question 3. I will quiz 3, question 3, F string. I might have done a little bit of copy and paste from the Ruby workshops once. Okay, so variable scope. This describes where a variable can be accessed. Now in Python, that's based on where variables are initialized. And that means that variables have function scope. So a variable initialized inside a function is available only within that function. So no code outside of the function can access that variable. So to look at this, we're going to create a new function. We're going to review our pasta source. So I'm just going to create a new file, reviews. I'm just going to open it up. So now I'm inside my reviews file. I'm just going to paste in a gist for the people coding along into the chat and then copy and paste the code in. Okay, so we've got a function here, review, doesn't have any parameters. We've got a local variable rating, got a variable rating, and it's assigned to the string 5-star. And then we're printing this meal was 5-star. Then on line 5, we are invoking that method. So that will run this code. And then on line 6, I'm trying to print that variable rating just to see if I can access it outside. Now, again, VS Code is being very helpful to me here. It's got a squiggly line under there, which is suggesting to me that something might not work as I want it to. So if I just save this and then I want to run this code, I do get this meal was 5-star. So that is executed. But I then get an error because variables created, initialized, declared inside a function can't be accessed outside of that function. So what about if we moved this? So if I just move it up and outside, we need to do that. Up and outside of the function. So I am declaring this variable outside of the function. Can I access it inside the function? Let's have a look. Let's see if that works. Yes, it does. This meal was 5-star and get 5-star at the end. So variables that are initialized outside of a function can be accessed inside a function. So this worked. We've got access to rating here. So we did get this meal was 5-star, and then we've got the second 5-star underneath as well, because obviously, I think it's obvious, because this variable was declared outside of this function, it's also available outside here as well. So this is all outside of the function, and this is outside of the function. So on line 7, we can still access rating. Now let's have a look at what happens if we assign a different value to rating inside the function. So I've got rating being assigned on line 1, and then on line 4, I'm assigning it to 1-star. So here, I'm just going to save that file and then have a little think what's going to be output by line 7, and then what's going to be output by line 8. So we've looked at these first 2 concepts here. These 2 concepts here we've looked at. We're now looking at variable shadowing. So let's have a look and run the code. Here we get this meal was 1-star, and then we get 5-star. And that's variable shadowing. Because we've created a variable called rating inside the function, that means inside the function, when we are trying to access rating here, we're going to be getting this rating, not the one out here. And we can tell they're not the same because when we run this, if they were the same variable, when we printed rating on line 8, we would get 1-star because we would have reassigned it. But we haven't reassigned it because they're not the same variable. We got this meal was 1-star, and then we got 5-star. So look, we've got this meal was 1-star, and then we got 5-star. That's because these are 2 different variables. So if you create a variable with the same name inside a function with the same name as a variable outside the function, you won't be able to access the variable outside the function because you've shadowed it inside. This is something that this is something that tripped me up quite a lot when I was first beginning to program, because I guess I wasn't very original with my variable names, so I was often using the same names. So you just need to be careful if you do use the same names, that it's okay, because you don't want to access the variable outside of the function. Okay, now our last topic is the difference between functions and methods. So all the function calls we've used so far have used the same syntax, and that has been the function name followed by parentheses. We may or may not have passed arguments in there. But Python also uses another syntax to call functions on objects, and that's called method invocation. So the syntax for method invocation is an object or a variable that references an object, followed by a period, full stop in British English, the function name, and then the parentheses. So let's modify our review function to include the reviewer's name. So here I'm going to, let's keep this simple. I'm going to get rid of the rating up here. We don't need to be printing this rating down here. So we've just got the function and then we are invoking it. So here I'm going to put name, and I'm going to put everyone's favourite celebrity chef, Gordon Ramsay. Or he'd be annoyed. I spelled that wrong. There we go. And then I'm just going to add that inside the F string. Okay. So here is a function invocation, but I want to demonstrate also a method invocation. So I'm going to do it on this one here. So if I do dot upper, name points to an object, it points to Gordon Ramsay, the string Gordon Ramsay, the string Gordon Ramsay. Then, so I've got my object, then I'm doing the full stop with a period, then the name of the method that I want to invoke, and then the parentheses. And so it will invoke upper on the variable, on the object that the variable references. And this is a method invocation. So they're both of these, this function invocation and this method invocation, are both invoking functions that are written somewhere, but we just have different terminology to refer to them because they are slightly different. So now if we execute this, we can see this meal was 1 star by Gordon Ramsay. You're going to meet lots of method invocations when you begin to work with collections, which is what we're going to be looking at next week, because there are loads of built-in functions that you can use with lists, dictionaries, sets. You know, part of the power of Python is all of these built-in methods that you can invoke on these objects. We're just going to now do our last sort of quiz of the topics. I've got a roundup quiz later for anyone who wants to stay for that. We're just going to do a quick quiz to check our understanding of variable scope and method invocations. So, yeah, I need to think about this, don't I? Because is this too small for people to see? Okay, so I'm going to launch this final topic quiz, give it a go, and I hope you've got better eyesight than me. Let's see if I can remove some of carriage returns and then zoom in. That worked, that did make it a bit better. Okay, so I'll give another 20 seconds or so. Okay, now let's look at the answers. Okay. So for the first one, this is demonstrating a local variable initialized in outer scope. Up here, we've got creeper. Is available inside the function. So we get creeper being output. For example, 2, we are demonstrating that a variable initialized inside a function definition is not available in the outer scope. So here we're going to get an error because there is no variable called scientist in this code that is accessible from outside of the function. Example 3, this is demonstrating the same as I demonstrated before, that the variable name outside of the function is a different variable to the one inside the function. So here, the path of execution actually is name equals Charles Babbage. Then we do first programmable computer and pass in name. Wow, this is quite a complicated example. So when we go into the function execution, name is assigned to Charles Babbage. Then name inside the function gets reassigned to Bugs Bunny. So we get Bugs Bunny created the first, but I think this should be Bugs Bunny. Did everyone else? 1, 2, 3, all bit split. Let's check this. The function doesn't have a print statement. Thank you. So, oh, so it's asking what print name would output, and it would output Charles Babbage. Thank you. Okay, I'm not going to test this because that's not what it's testing. So going back to this, we get name equals Charles Babbage. We then go into the function where name will be assigned to Charles Babbage. Then inside the function, name will be reassigned to Bugs Bunny. Then we've got this F string that isn't being printed and isn't being output or returned or anything. Then we go down to print name, and here it will output Charles Babbage because this reassignment inside here only affects the name variable that is inside the function and not the one that's outside the function. That was quite a tricky thing to throw in there. But it's just good to keep you all on your toes, I think, and thank you for your help, Melvin. So example 4, this is an example of a method invocation because we've got our object here, then a dot, and then the name of the function, the method that we're invoking. And then for the last one, this is a function invocation because we've just got the name of the function and followed by the parentheses. So that is a function invocation. Well done. And I didn't use that switch out. Okay, so let's do that. So now the summary. So what have we covered? We have looked at what is function. We've looked at parameters and arguments. We looked at, so that's how to get information into functions. And then we looked at function returns, so getting information out of functions. We then looked at variable scope, which is something that's covered in much more detail in the books and later on in the course as well. But basically, variables initialized inside a function can't be accessed outside, but variables initialized outside a function can be accessed inside the function. But be careful of variable shadowing. If you use the same name for the variable inside and outside the function, you won't be able to access the variable outside the function because you'll be shadowing it with the variable inside the function. And then we looked at functions versus methods. So functions are function invocations. We've got the name of the function followed by the parentheses. Method invocations, we've got our object dot function name parentheses. Right, that was a lot of information to cover in 1 hour. Don't worry if you didn't follow all of it, because learning is a circular process. You need to go over sometimes the same things a few times. And each time you're exposed to it, you pick up a bit more. So now is the time, if anyone's got any questions, pop them in the Q&A. And while I'm waiting for those to come in, let's do a roundup quiz for anyone that wants to stick around and do that. But I am aware that some people might need to hop off. So I'm going to put the feedback form in the chat again for anyone that needs to leave bang on the hour. But for anyone that doesn't, enjoy the quiz, and we'll go through the answers in a bit, and should go over all of the things that have been covered today. Okay, I'll give you another 20 seconds or so. I can see a couple of people have needed to hop off, but most of you have stuck around, so thank you. Okay, so let's have a look at those answers. Share the results with you. So what do functions return if there's no explicit return statement? They return none. So if you don't have a return statement in there, it will just return none. It's not nothing. And it isn't last expression evaluated. Other programming languages do that. Python just returns none if you don't have an explicit return. So how is information passed into and used inside functions? We use arguments and parameters to pass information into a function. And then for question 3, to get information out of a function, we use return values. Just going to get rid of that rogue comma there. It's bothering me. Question 4, function definitions can access local variables initialized outside of the function definition. That's true. So if you've got a variable initialized outside of a function definition, you will be able to access it inside the function. But for question 5, variables initialized inside the function definition can be accessed outside the function definition. No, they can't. That's false. So if a variable is initialized inside a function, it is only available inside that function. And that can catch you out. Especially as different languages do different things with this. You just learn what the language is doing that you are learning right now. Okay, so that is the end of the workshop. So let's just have a look at what we're going to be doing next time. So slideshow. So today we did functions and variable scope, and next time we're going to be doing flow, control, and loops. So that is looking at how we can alter the path the program takes. So today, program is just working from top to bottom. But next week we're going to be using if statements. So depending on what we want, different things can happen, and then also match case statements, and then loops. You want the same thing to happen a number of times, which is quite a common paradigm to use in programming. So that would be quite fun. So join me next week. Other than that, I just want to say I hope you've enjoyed it. Please fill in the feedback form so that I know, what has worked, what hasn't worked, how to improve it for the next cohort that go through this. We read every piece of feedback we get at Launch School, and it's because we get such useful feedback that we can just improve the material all the time. Yeah, please fill in the feedback form. And Brandon, you're welcome. So I hope everyone has a great weekend. It's 11 o'clock for me in the UK, so it really is my weekend now. It's quite a nice way to end the week, actually. Yeah, and see you all next week. Goodbye.